This is for Year 12 methods. We're going to look at trial 3, a question from it. So it's to do with getting the range of a composite function that, you have no idea what it looks like, okay? So first of all, we know the domain of golf is equal to the domain of f, which equals to infinity, okay? So it's always the domain of inside. That's the restriction you place on the rule of golf, okay? So this root function. Now, the root function has a rule that goes like this. Now, how do I apply this domain onto this rule? Okay, all you have to do is look at the behavior of the rule at its endpoints. Okay, even though we can't sub in, even though we can't physically know what the graph looks like, but we can roughly sub in to get an idea of like looking at the limits of what happens at 2 and infinity. Okay, so if you think about it, if I sub in, okay, you can't do this mathematically, but theoretically, as x approaches 2, and we're going from 2 to infinity, meaning you're approaching x, you're approaching 2 from the right, so right hand side, like in, you're approaching x from the right. What happens is, obviously it can't it can't equal 2 itself, because if you sub in 2, that function becomes 2 divided by 0, which is undefined. But if I sub in a value, if I get very, very close to 2 from the positive version, so picture me going from the value of, let's say a very large number, let's say 10,000 to 1,000 to 10 to 3 to 2.5 to 2.4 to 2.3 to 2.2, 2.1, 2.001, 2.00001. Okay, it can be a number greater than 2, but it can't be 2 itself or less than 2. So what happens is, if I have a number like say 2.001 and minus 2 from it, 2 divided by 0.001 is a very large number, isn't it? Okay, because if I got 2.0001, that's a huge number. But I can approach 2 as close as possible. So if I got 2 divided by 0.000001, you can see that's a huge number. So what happens is, as I approach 2 from the right hand side, is this is going to approach infinity. So if I've got the square root of infinity, essentially, if I've got square root of infinity plus 2 plus 1, that's infinity. Okay, so the upper part of my range has to be positive infinity. Okay, I can't be negative, because remember, x cannot equal, it can't equal 1 point, 1.99999999991. Otherwise, that'll be a negative value. Okay, I can't do that, but it can be a very, very it can be a 2 value with a number attached, with a decimal attached to it, that's like 0.00001, 000, like many zeros to 1. So essentially, this will blow up to infinity, okay, on that side. Now, conversely, if x approaches infinity, what will happen? Well, if you've got 2 divided by infinity minus 2, it's the same as infinity. If infinity is, the largest number possible, even if you minus 2, it's still infinity. 2 divided by infinity is infinity, isn't it? Okay? So, sorry, 2 divided by infinity is, if I go 2 divided by a very large number, and infinity is as large as they get, that's going to approach 0, okay? So, if that's approaching 0, you're left with the root 2, okay? Root 2 plus 1. So that's why the range of golf is root 2 plus 1 to infinity. So essentially what you're doing is you're finding what happens as x approaches 2 from the right and x approaches infinity, and they give you an idea of what the endpoint equals to. Okay, so in these ones, you can't physically draw the graph. You don't know what the graph looks like, so you can't go, use your knowledge of, say, correct, if the composites are correct, you can obviously get the endpoints from that. But in this case, you can't. You have to picture what the limit is from for each of the endpoints. Okay, so hopefully that explains how that works.